All right, so now we're in section, well, this is really 7.2. 7.4 was the previous video because it doesn't line up with the homework, but this is in 7.2. And this is where it starts to go, didn't we do all this in chapter 6? Because in chapter 6, there was the z-interval. And now there's the z-test. And there was the t-interval. And now in the next video, we'll do the t-test. And then there was the one prop z-interval. And last video, we did the one prop z-test. Oh, yeah. All right. So it all starts to look kind of the same. And it's the same exact, okay, the prop goes with yes and no questions, which is what I said last time. Okay, and the interval, or the z-interval, that goes with n is greater than 30. Okay, and the same thing with the z-test. So these are numbers questions, like how tall are your basketball players? Okay, and somebody's got to answer in numbers. Same thing with t, except n is less than 30. So it's exactly the same. The way to tell the difference is in the intervals, there's just the one person. So there's only one mean anywhere to be found in it. And in tests, there's two. There's the one person makes a claim and somebody else goes out and actually gets some real numbers. Okay, that's how to tell the difference. This one person is involved, that's two people involved. All right. And luckily, there's like a bunch of calculator buttons, and the same way that those ones, the intervals, match up with those three things, the exact same situation with those. Now, in the interval section, there was also that chi-squared. You had to find the chart, look things up. Fortunately, there isn't one of those. All right, so this problem, the average height is over 6 feet. That's question number 4. Okay, and I didn't write it down here. N is 30 here. So because n is 30, this is, all right, there's two people involved. It's definitely a test. It's a numbers question. How tall are you? So that would be like a z or t test. Okay, but n is 30, n greater than or equal to 30. All right, that's a z test. Now, if I thought n is 30, if I thought a couple of the people I talked to were a little shaky and not very reliable, maybe I would go ahead and call this a t-test, because t just gives you ever so slightly more wiggle room. Anyway, all right, so now I have to write down the hypotheses. Don't read any of the survey stuff. Go straight to the claim. All right, the average height is over 6 feet. That's greater than 6 feet. Mu is greater than 6. And that's what I did in like that first video, is you have to put, if they don't say or equal to, you have to put it right there in the H1. You can't put it in the H0. The math works out. You got to have an equal sign in your H0. So I have to put it in my H1. Then I put the opposite of that in my H0. Great. Now I got enough stuff. I go to the calculator. Stat, tests, z-test. It's the very first one. I'm inputting stats, mu0. Now, anytime it has that little 0 down there, it just reminds you that's the other person. Other person said 6. So put that there. Then it says sigma. All right, sigma is 0.3. X bar, that's me, 6.1. And n is 30. And then there's that line underneath that says not equal to mu0, less than mu0, greater than mu0. That was what you were supposed to match up with whatever is H1. You can never match up with H0 because there's no or equal to. This is how the calculator is taking into account you wrote down something in your hypothesis. So I got to match that up with greater than, and hit enter to make it stick, and down to calculate. Okay, it says Z is 1.83, P is 0.034. All right. X bar is 6.1, that I already knew. N is 30, that I already knew. Okay, now I need to reach some sort of conclusion. And for reaching the conclusion, you use this P right here, and you compare it to 0.05. 0.034 is less than 0.05. Okay, and this 0.05 is always going to be 0.05. It's the industry standard. It's like saying the 95% on the confidence. It's the opposite of that. It's a 0.05 significance level. And pretty much everyone always uses 0.05 to compare things to. This is the chance that the person who said H0 was right. They have like a 3.4% chance of being right. And if they had even a 5% chance of being right, I'd let it slide. But 3.4%, nope, they're wrong. Okay, because this is less than 0.05, then reject H0. Okay, well, that's good. And then if I walk away, I followed the whole procedure, and if I walk away from the problem right now, I feel pretty good about it. Okay, if I go back and read the thing, what I just said is reject H0. Nobody even said H0. The person who was making the claim said H1, and I just rejected something that nobody said. And if you look at it, I got 6.1, and they said over 6 feet. We're actually in agreement anyway. But this is the way the math works, okay? You just write down reject H0, even though it has nothing to do with anything anybody said, and you'll walk away from the problem. In real life, you'd probably track them down and try and get them to say greater than or equal to or something so you could test it properly. But here, we're just going to write down reject H0.